Today I'm working on a Kingston SSD. The unit doesn't get recognized on any system. Usually there are two types of problems. Either the unit is physically defective, there is some component blown out, or something is disconnected, and there is issues related to degraded memory and corrupted firmware and other things that could also prevent your access to the data, which PC-3000 can help as long as it supports that type of controller. The good news for us is that this SSD controller is supported by PC-3000 Portable. Let's do some preliminary tests. You gotta remove the sticker, put this SSD into an adapter for port 0. This device should recognize that it's an NVMe. We want to check what these lights come up like, what consumption levels we get, and overall whether or not we can see the passport of the unit. Power on, we get the HY light come up. We're taking in 360 milliamps, which is, for this type of device, is perfectly adequate. This is a 63XT controller. I think we can do as Kingston, right? Kingston does not have that. Let's try ADATA. I'm trying to run ADATA for Silicon Motion, and this thing is just bugging. It's not letting me in. It just sits, tells me initialization is taking place, but nothing really takes place. It's hanging up. We're gonna put it directly into a safe mode. How do we put the device into a safe mode? On this device here, we have these two holes. If we jam them with a tweezer just like this, then power on device through the utility once again, we should end up in a safe mode. Let's see. Power up. 290 this time. But if we go into universal utility, it's going to recognize the controller and it's not hanging up like it did before. You see SM2263. At this point, we can auto select what we want, but we can tell it, let's go and explore ADATA utility and see if the 63XT controller exists in there. It doesn't, only 62. Let's go to the next one. Let's try AMD. It's hard to remember them. Yeah, AMD is gonna do it. You see SM2263 controller is present. That's what we want to see. That's what we want to work with. Let's go utility start, and automatically is going to try to load a loader for us, because this utility understands that the device is already in a safe mode. So we got a couple of options here to choose from. I'm just gonna go with the first one that it suggests. I don't know if there is a specific way of choosing them. If one doesn't work for me, I go to the next one. That's how I choose them. It says where tables are not found. I honestly don't know how long this process can take. It depends on different manufacturers. Will require different times. I've seen some cases that go into many hours, but hopefully this one isn't one of them. All right, so the loader is in. We're gonna go first thing, test all the memory chips, right? So this memory chip test is going to tell us if we have any abnormal counts for amount of banks and chips. Here everything looks even. This is the capacity of each unit, so 128, and we got 8 of them, so that makes sense that it comes out to 1 terabyte of our device. That's what we need to see. So the next thing we're gonna do is we're gonna go into translator, and we're gonna let's say save to file, and saving a translator to file will start creating it, but it will also save it on a disk for us. So in case if we need to power down, in case if there is power outage, realistically guys, let's see, we got a weather warning up here. We're expecting 20 centimeters of snow today. It was like plus 15 yesterday, and they're telling us it's gonna have 20 centimeters of snow today. So in case there's a power outage, if we create this translator to file, we'll be able to load it up next time simply by selecting it and uploading it. We don't have to wait for it to be built, because again, building the translator is not a process that takes few seconds. It's going to read for a while. It's going to analyze stuff that it read, going back and forth. It's going to take some time. No matter how you look at it, it's going to take some time. There we go, the translator is built. Alright, so we're choosing this as our source, and I'm gonna image it into a virtual disk as the target. Let's see if we can read this device. It says table of partition is empty. Do we want a quick analysis or no? We can run a quick analysis and see if it can come up with something that resembles the type of partitions that we're looking for. Again, this process can take a while, but we still have to do it. At this point, we're not able to run a complete image of this whole thing, but we can let it run for a little bit, and then we can see what comes up in raw recovery at least. We're wrapping up to our 5 million mark. Rereading these bad blocks on this unit may turn out to be not such a bad thing, because if we're able to, let's say, capture a decent amount of them, we can assume that information that we've had to skip through at the beginning is going to be all intact. Let's go into submap creation. We're going to create submap of all of these black sectors. All right, so we're going to select all of this and set it up to read. Let's go back. As you can see, some of them do get picked up. It will require more work. If we don't come up with anything in the raw scan right now, then I guess we'll have to get that done a bit more thoroughly. So I'm going to select raw recovery option here. I'm going to change this to 5. The thing I like here the most is the fact that it found these things here: BitLocker, volume header, especially. So when I first got into this project, I talked to the client, and he explained that there is a partition, it may have BitLocker on it. He has the option to get the key if it's necessary. If we run the file system search, will it be able to find something when it reaches 5 million? No, and we didn't image the unit further, right? But if we go into raw recovery, volume header right here. So you see this sector number right here? I'm gonna copy it. We need to create a virtual disk and change our partition table so that it understands that this is where our volume begins. Because you can see 55 AA signature here. It looks like a first sector for the partition that we're looking for. If we go back to our main screen here and open up first sector, let's save this thing here. Save to file. We're going to call it sector 0. Now we can fill it all up and save it. Now we have a blank sector at the beginning. What if we view this sector as our partition table? We know the system would be 07 for this. Relative sector, where it starts, is what we saved in our buffer. And the only thing I should have checked is the amount of sectors that we have. Let's just go back to this. So it's 2 billion. We're going to relatively round it up to 2 billion. So again, let's go into this sector 0, partition table. I'm going to call it 07. Paste. 2, 1, 1, 1, 3, 3, 3. Apply. So now we have something new in here. Look what just appeared here. It's a BitLocker partition. And the only thing we need is the key. So let me quickly text my client, get the key, and then we'll see if we can get in. All right, so I was able to get the key. The key is in. Let's see what the device will find. So it added a new drive, which now, as you can see, has NTFS OS partition on it. And if we go into maps and look at the MFT map, we can see that there's 700 megabytes of MFT. So as a result, I was able to clone most of this drive. Yeah, I did have a small portion of bad blocks, but nothing major, nothing critical. If we go into task statistics, you can see that out of nearly 2 billion successfully read sectors, we have absolutely nothing that wasn't read. We have slightly over 2 million problematic ones. How many damaged files we end up having after the saving process is done, we will only know after the saving process has been finished, because Data Extractor has a very convenient feature of checking integrity of files across the map of extracted content while it's saving the files onto the target media. So when we present a hard drive to a client, usually the data is going to be split up into two categories: intact folder and files that potentially may not work. So all those files that have bad sectors will eventually be isolated in that may not work folder. But as a percentage of how much bad sectors we've accumulated at the end of this recovery procedure, it yields to 0.12%, which is a really small fracture. If somebody told you that you're going to get 99.9% recovery, I'm sure you would be more than happy with that. Now, the amount of files that have those bad sectors may turn to something greater in size, because if one bad sector is inside of 20 gigabyte file, for example, that 20 gigabyte file is going to be automatically put into that may not work folder. But that doesn't mean that that file doesn't work. It needs to be checked. It needs to be manually tested to see if it's functional or not. So overall, it's a great outcome, guys. And this is where PC-3000 came in extremely handy, because I would not have been able to get that case solved, at least without extensive persuasion of tech support and developers to make that happen on platforms like RStudio or UFS Explorer.